with question 26, this is what we have. We are multiplying two expressions together. So let's write it down. We have 2x plus y by 2x minus y. All right, so this is the question, and this is what you have to note. This by this means this multiplied by this. So let's rewrite it. We have 2x plus y multiplied by 2x minus y. This is what we have. So this is multiplying this. And I've noted something over here. These two expressions give us what we call difference of two squares. And with difference of two squares, when you have the value over here, okay, the expression over here is the same as the expression over here. And this expression is the same as this. The only thing that changes will be their operation. When the only thing that changes is their operation, then if here is positive and here is negative, or if here is an addition sign and here is subtraction sign, then since all the expressions over here are the same and only the operations that change, which are addition sign and then the subtraction sign, then this is what we have to do. We only take the first expression, 2x, we square it, minus the second expression, then we square it. That's what difference of two squares mean. So with difference of two squares, you only have to take this, one of the expressions, 2x, square it, then minus, take the second expression, which is y, square that one too. All right, this will give you the answer. So after solving this, you have the answer. When you have 2s squared, it means 2 is squared. 2 squared will give you 4. All right, and then x squared will give you x squared. Then minus, when you have y squared, it will give you y exponent 2. So when you expand this, you have 4x squared minus y squared. This is the difference of two squares. The only difference between the two expressions is their operations. There is an addition sign and there is a subtraction sign. The expression here is the same as the expression here, and the expression here is the same as the expression here. The only thing that changes over here is their operations, addition and subtraction. You only stick to addition and subtraction. If you have addition and subtraction signs over here and the expressions over here are the same, you only have to take the first expressions, square it, minus the second expression squared, and then you obtain the answer to this particular question. So this is based on what we call difference of two squares. Anyway, there is a second method to solving this. You can go ahead and then take each of the expressions to multiply the other expression in the bracket. That will also give you the same answer. We can try that one out. Let's give it a try. So we take 2x plus y, then we have 2x minus y. So 2x multiplies 2x, we have 4x squared. 2x multiplies minus y, then we have minus 2xy. Y multiplies 2x, we have plus 2xy. And then y multiplies minus y, you have minus y squared. So over here, we have 4x squared, then minus 2xy, and then plus 2xy. 2xy, 2xy, they are like terms, so we can find their final sum. Okay, so this is negative 2 plus negative 2. It boils down to 0. So it's the same as 2xy minus 2xy. That will give us 0. So all these expressions over here will give us 0. So we only have minus y squared left. And this expression is the same as this. That was what I was talking about, that we have this to be the difference of two squares. So there is no need worrying your head, expanding the whole bracket. Once you notice the expressions are the same, and the only thing that changes will be the operations. You have an addition sign and then a subtraction sign over here. You only take the first expression, square it, minus the second expression squared, and you obtain your answer. So we are done with question 26. We box on and then take a look at question 27. All right, guys, so with question 27, this is what we have, okay? A man receives a basic wage of 250 cedis a day. So every single day, the watchman receives 250 cedis. If he works every day for a month, his wage, his basic wage in the month of February 1988. Now, we know that February has either 28 days or 29 days. So this is by going or skimming through the methods by choosing whether it will be 28 days or to be 29 days, all right, within that particular month in February 1988. So with the analysis I made, I found out that it was 29. Do we get it? So if it is 29, then it means that if you have 29 days in February 1988 and the man is paid every single day 250 cedis, and it means you just have to multiply 250 cedis by the number of days that he works in that particular month for you to obtain his basic wage for that particular month. So this is just simple multiplication. Just multiply the number of days. So in February 1988, we have 29 days, all right, in that particular month. So 29 days in February 1988. It has 29 days. So multiply the 29 days by his daily wage or daily pay that he is given. So his daily wage is equal to 250 cedis. So for the month of February, he is going to receive 29 multiplied by 250 cedis. So every single day, 250 cedis. Every single day, 250 cedis for 29 days. All right, so it is 250 cedis multiplied by 29. So let's find the product. So we have 250 multiplied by 29. We are multiplying vertically. So 9 multiplies 0, we have 0. 9 multiplies 5, we have 45. We write 5, remainder 4. Then 9 multiplies 2, we have 18. 18 plus 4 gives us 22. 2 multiplies 0, we have 0. 2 multiplies 5, we have 10. We write 0, remainder 1. 2 multiplies 2, we have 4. Plus 1, we have 5. So we find the sum of this. We have 0 here, 5 here, 2 here. We add this, we have 7. So we have 7,250. So this is it. See this. So for the month of February, and in the year 1988, it means that the man received 7,250 cedis. That was his basic wage for that particular month. So question 27 is solved. Let's box on, take a look at question 28. So with question 28, we have a tank containing 250 liters of water, and if they used 96 liters of water from that same tank, what percentage of the original quantity is left? So let's write certain things down. Liters of water in a tank. So let's write it down. So liters of water in a tank is equal to 250 liters. And then liters of water used. Let's write it down. So liters of water used, we have it to be 96 liters. So we are finding the percentage of the original quantity left. So if the tank contains 250 liters of water, and then the liters of water used is 96 liters, then what liters of water is left in the tank? We will need to subtract 96 liters, that is the liters of water used, from the total liters of water in the tank. So liters of water left, let's find that one. That will be 250 liters minus 96 liters. And this will give us, let's find the difference over here. If you have, let's do it over here, 250 minus 96. We borrow 1 here, we have 10, 4 is left. 10 minus 6, we have 4, 4 is left here. We borrow 1 here, then we have 14. 1 is left here. 14 minus 9. Then we have 5. I remember 1 over here. So 154. So we have 154 liters of water left in the tank. So if we have 154 liters of water left in the tank, then the question demands that we find the percentage of the original quantity left. So we are finding the percentage of water left in the tank. And this is the liters of water left. So to find the percentage of water left in the tank, it will be the liters of water left in the tank out of the total liters of water in the tank multiplied by 100% of water left in the tank will be equal to, so that will be equal to liters of water left in the tank, which is 154 liters out of the total liters of water in the tank, 250 liters, multiplied by 100%. So divide here by 10, you have 25 left. Divide here by 10, you have 10 here. Divide here the 25 by 5. Then divide here by the same 5, you have here to be 2. So let's box on and then find the value itself, the final answer. So now we have 154 over 5 multiplied by 2%. Let's multiply 154 by 2. So we have 154 multiplied by 2. 2, 4, 8, 2, 5, 10. We write 0, remainder 1. 2, 1, 2 plus 1 is 3, 308. So we have 308 over here. When 154 multiplies 2, you have it to be 308 over 5. So we have it to be 308 out of 5%. So let's calculate for this. 308 divided by 5. Let's solve it right here. Go by the long division method. And this is it. So 5 divides 30. We have it to be 6. 6, 5, we have 30. So this gives us zeros. The 8 comes down. We have 5 divides 8 a single time. 1, 5, we have 5. And then 8 minus 5 gives us 3. So 5 can't divide 3. Bring a decimal point here. Add 0 to the 3. 5 divides 30 and it is 6 times. 6, 5 is 30. Find the difference, you have 0, 0. All right. So we are done with the long division method. So we have it to be 61.6%. So continuing from here, dividing 308 over 5%, we have it to be 61.6%. So the percentage of the original quantity of water left in the tank will be 61.6%. And question 28 is solved. Let's box on to question 29. So with question 29, we are evaluating this under common fractions. So addition, subtraction, division, and multiplication of common fractions. So I'm writing the question down. We have it to be 10 divided by, to bracket 3 whole number 1 out of 2 plus 1 whole number 1 out of 5. So we use board mass. We solve the one in the bracket first. So we write 10 divided by, change all the mixed fractions to improper fractions. 3 multiplies 2, 6 plus 1, 7 out of 2. Then plus 1 multiplies 5, we have 5. 5 plus 1 is 6, 6 out of 5. Now let's find the LCM for both fractions. So the LCM for 2 and 5 will be 10. Find the LCM over here, 10. 10 is the LCM for 2 and 5. The denominator is over here. So 2 divides 10, we have it to be 5. 5 multiplies 7, we have it to be 35. Plus 5 divides 10, we have it to be 2. 2 multiplies 6, we have it to be 12. So rewriting, we have 10 divided by 35 plus 12, we have it to be 47, or out of 10. So we are back to the same spot again, and now we have got to divide this. And when dividing, there is the need for us to find the reciprocal, all right? We change the division sign to multiplication sign, and then we find the reciprocal of the second fraction. So let's rewrite this whole thing. We have it to be 10 divided by 47 out of 10. We can write this 10 as over 1. So we maintain the, going forward from here, we maintain this 10 out of 1. Then the division sign changes to multiplication. 10 goes up. Denominator 10 becomes the numerator now. It goes up. We have 10 up, and then 47, which is the numerator, comes down. Now it becomes the denominator. So we have 47 down there. So over here, 10 multiplies 10, you have it to be 100. 1 multiplies 47, you have it to be 47. So right from here, if you check and there is no answer related to this, then it means we have to change this to a mixed fraction. 47 can divide 100, it seems 2 whole times. So 47 will divide 100 2 whole times. And when you multiply the 2 by 47, you have 94. All right. When you subtract 94 from the 100, you have a remainder of 6. So 6, and then out of the 47. So 47 will divide 100 2 whole times. There will be a remainder of 6, and then over the denominator 47. So the final answer is 2 whole number, 6 out of 47. And question 29 has been solved. Let's box on and take a look at question 30. So there is a question on probability over here. A bag contains 24 marbles. So total number of marbles in the bag, let's write it down. So total number of marbles in the bag, we have it to be 24. And then out of the 24 marbles, 10 are blue. So number of blue marbles. So with the blue marbles, we have them to be 10. So we have 10 blue marbles. And then the question is demanding that we find the probability that the boy picks a green marble from the bag. And we don't know the number of green marbles. With the number of green marbles, this is how we go about it. We subtract the number of blue marbles from the total number of marbles in the bag. And the remaining marbles will be the number of green marbles left in the bag. So, number of green marbles. So with the number of green marbles, we have both the green and the blue marbles in the bag, and they together result in a sum of 24 marbles in the bag. So if we have the number of blue marbles to be 10, then the remaining left in the bag will be the number of green marbles. So to find that, we subtract the 10 blue marbles from the total number of marbles in the bag. So it will be 24 minus 10. And this will give us a difference of 14. So the number of green marbles in the bag will give us 14, or will be 14. So the probability that the boy picks a green marble will be the number of green marbles. So the probability that the boy picks a green marble will be equal to the number of green marbles, out of the total number of marbles in the bag, out of the total. Do we get it? And the number of green marbles in the bag, now we have it to be 14. And the total number of marbles in the bag, we have it to be 24. So let's leave this in the simplest form. 2 divides 14 and 24. So 2 is the common factor that we are going to use to divide. So 2 divides 14 7 times. 2 divides 24, we have it to be 12 times. So over here, question 30 has been solved, and the number of green marbles that we found is 14. The number of blue marbles from the question is 10, and the total number of marbles in the bag is we have it to be 24. So the probability that the boy picks a green marble will be 7 out of 12. So question 30 has been solved. Let's box on, take a look at question 31. The question 31, the question is displayed on the screen, and the question demands that we select one of the alternatives to match or represent the illustration that we have on the number line. So let's see, taking a look at the number line, the circle linked to the arrow moving to the right is not shaded. So if the circle, this is not shaded and it is moving to the right, it means that all the values moving to the right are larger, are bigger than the values to the left hand side. So if the circle has not been shaded, it means that the sign that we are going to use is not going to be this, neither is it going to be that. These two are out. All right, it is either going to be greater than or is less than, one of these. But let's see, this is also located on -3, and once it is not shaded, it means that the values don't begin from -3. It begins from the next value, and the next value after -3 to the right is -2. All right, so when you are listing the values for this particular illustration, you begin from -2. But let's take a look at it. It means that all the values to the right of -3 are greater than -3, and it's going to be n. All right, n is greater than -3 because all the values moving to the right are greater than -3. -2 is greater than -3. -1 is greater than -3. 0 is greater than -3. 1 is greater than -3. 2 is greater than -3. So all the values to the right are greater than -3. So to illustrate this, it means that n is greater than what? -3. All the values, n is representing all the values over here. And n, the values over here, are greater than -3. So that is how we find the answer to question 31. So we box on to question 32. So with question 32, this is what we have. The question says, what is the name of the line segment drawn to join any 2 points on the circumference of a circle? So if you have any circle, if we take this to be any circle, if I draw this, and this is a circle, and I draw any line from this part of the circumference of the circle to touch another part of the circumference of the circle, a straight line like this, then this line that I've drawn will be called a chord. From one circumference of the circle to touch another circumference of the circle, then this line that I've drawn is called a chord. So number 32 is a chord. The answer to number 32 is chord. And we are done for number 32. So with number 33 and 34, we are using this mapping up here. All right, so let's box on and take a look at question 33. With that particular one, there will be the need for me to write these preambles from the mapping. So let me put that particular one down, and then let's continue with it. So from the mapping, this is what we have. So this is what we have from the question, and question 33 demands that we find the value of x. So this is where we have x, and then for us to be able to find the value of x, there is the need for us to understand this whole mapping. Okay, this is where we have between this and that. This is the domain, and this is the codomain. So if you have half, then when you go to the codomain, it becomes 1. you have 1, it becomes 2. If you have 2, it becomes 4. You have 3, it becomes 6. What about if you have 4? It will become 8. You have 5, it will become 10. That is how this mapping goes between this domain and this codomain. That is how it flows. And then over here, when you have 1, it is 3.14. When you have 2, it is 6.28. When you have 4, it is 12.56. So let's find the value of x. So between this and that, let's take this as the domain and this as the codomain, all right? When you take every one, all right, every single one, it is 3.14. So if every single one is 3.14, then what will be the value of x? If when you take 1, it is 3.14, what will be the value of x? So over here, we had 1, and then we had 3.14. When we had 2, we had 6.28. And before you obtain 6.28 over here, you will need to multiply these two by 3.14 to obtain 6.28. To obtain 12.56, there's the need for you to multiply 3.14 by 4 for you to obtain this. So it means that to obtain the value of x, there is the need for us to multiply 3.14 by 6 for us to obtain the value of x. So to find x, we multiply 3.14 by 6. So there is the need for us to multiply vertically to obtain the answer for x. So to multiply vertically, we will multiply them as if there were no decimal points, okay? So over here, we write 3.14 as 314, and then multiply it by 6. Note that from here, we have 2 decimal places. After the decimal point, we have 1, 2 numbers over there. So we have 2 decimal places. After multiplying 314 by 6, we will apply the number of decimal places that we have here. The 2 decimal places, we will apply it to the final product that we get after multiplying 314 by 6. So let's box on and multiply. 6 4 gives us 24. We write 4. Remember 2. 6 1 gives us 6. 6 plus 2, we have 8. 6 3 gives us 18. So this is what we have, 1,884. That is for the product. So let's apply the number of decimal places. Over here, we had 2 decimal places. We had no decimal place over here. So in sum, we have 2 decimal places. So if we stand here, we apply the decimal places by moving 2 times to the left. So 1, 2. So we have it to be 18.84. And this is the value of x from the mapping over here. That is the value of x. So x is 18.84. We are done with question 33. Let's now box on and take a look at question 34. And with question 34, there is the need for us to find the value of y. How then do we find the value of y? From here. Note this. Over here, when you have half, if this is the domain and this is the codomain, if you have half, it is 1. If you have 1, it is 2. If you have 2, it is 4. 3 is 6. All right. Then y is 10. It means that over here, when you double each of the values that we have in the domain, you obtain the value in the codomain. So when you double half, you have 1. When you double 1, you have 2. When you double 2, you have 4. When you double 3, you have 6. So if you double y, you have 10. And it means double means that you multiply the value in the codomain by 2. So if you multiply half by 2, you have 1. Let's try that one out. Half multiplied by a constant 2. Let's see the answer we are going to get. 2 will divide itself a single time, divide this to 1. 1 multiplies 1, you have 1. And we have 1 here, becomes the denominator. 1 out of 1 will give you 1. And that is the one that we have over here. All right. When you take 1 and you double that one to this particular one in the domain, when you take 1 in the domain and you double it, multiply it by 2, you have a product of 2. And that's the 2 that we have here. So it means when you take 2 and multiply it by the same constant 2, you have 4. When you take 3, multiply it by the same constant 2, you have 6. So if you take y and multiply it by the same constant 2, you have 10. So if you multiply this y by 2, the answer will give you 10. So if you multiply this y by 2, so 2 multiplies y, the answer will give you 10. So let's find the value of this y. This will give us 2y. 2 multiplies y, we have 2y. and it will be equal to 10. 2y will give us 10. So to find the value of y, let me repeat this. 2y is equal to 10. To find the value of y, we need to divide this y by the coefficient, which is 2. So divide y by 2, and then you have this, divide 10 also by 2. So we divide here by 2 because we want y to stand alone. Divide here by 2. And what you do at the left hand side, you make sure you do the same thing at the right hand side. So divide here by 2, divide the right hand side by the same 2, which is the coefficient of the y. 2 divides 2, you have only y standing. And then when 10 is divided by 2, you have 5. So the y over here is 5. And when you double y, when you multiply 5 by 2, the answer will give you 10. So the value of y is 5. And we are done with question 34. So with question 35, the question is displayed on the screen. The question says the area of a square is 49 centimeters squared. Let's put that particular one down. Area of the square is 49 cm squared. Find the perimeter of the square. So let me draw a square over here and use it for my explanation. So if the area of a square is 49 cm squared, what comes to mind? What formula do you use to find the area of a square? The formula used will be area of a square will be equal to, it is the length multiplied by the length, because we know a square to have the length of all its sides to be congruent. So once the length of all the sides of a square are congruent, then it means that to find the area of the square, we just need to multiply one side of the square, the length of one side of the square, by another length of the other side of the square to obtain the answer. So if this side is the length, this side is the length, this side is the length, and this side is also a length. To find the area, just multiply either this side by this side by this side, or this side by this side, or this side by this side. So I go for this, length multiplied by length, so L times L gives you the area of the square. And we've been given the area already. We are not told to calculate for the area, but we are rather calculating for the perimeter of the square. That is what we are calculating for. But we will need to calculate for one side of the square, the length of one side of the square, before we'll be able to find the perimeter of the square. So let's find the length of the square. So the area is given by length times length. So the area of the square 2 is 49 cm squared. So we have 49 cm squared, which is equal to length multiplied by length. This is the area of the square, and the formula is given by length times length. And 49 cm squared will give us length multiplies length, and then you have it to be length squared. All right, so let's rewrite this same thing again. 49 cm squared L squared. With this, to find the value of L, we just need to find the square root of this and then square root of this. So this gives us the length of the square. This gives us the length of the square, and then square root of 49 is 7, and this gives us the unit in centimeters. This is it. You search for a particular number or value that when you use it to multiply itself, you obtain 49, and that is 7. When 7 multiplies 7, you obtain 49. So the length of the square is 7 centimeters, and that's what we have. So to find the perimeter, the question demands that we find the perimeter of the square. And let's use P to represent perimeter of the square. So if P is the perimeter of the square, that will be equal to, what formula do we use to find the perimeter of a square? It is 4L, or 4 times 1 length of the side of the square. This is the square. So to find the perimeter will be the distance, the whole distance around this whole square. So if one side of the square is measuring 7 centimeters, it means that here is measuring 7, here is measuring 7, here is measuring 7, and here is also measuring 7 centimeters. So you add all these lengths together to obtain the perimeter of the square. So the perimeter of the square will give us L plus L plus L plus L. So L plus L plus L plus L. And this gives us the perimeter to be L plus L plus L plus L gives us 4L. So it means 4 will multiply one side of the length of the square. So 4 multiplies, and then L measures what? 7 centimeters. That's what we have over here. So 4 multiplies 7 centimeters, and then we have P, which is the perimeter of the square, to be 4 multiplying 7. 4 multiplies 7, you have it to be 28. So 28 centimeters. With perimeter, you don't have it to be centimeter squared. It is just the distance around the square. So that is in centimeters. Whether it is in meters or millimeters or whatsoever, you leave it in that base unit. If it is area, then you have it to be squared. If it is volume, you have it to be cubed. As simple as that. So the perimeter of the square gives us 28 centimeters. We are done with question 35. Now we can box on and then take a look at question 36. All right, guys, so quickly let's box on and take a look at question 36. So over here, from the question, the real numbers that we have, the least number is 24. So the least real number is 24, and then the greatest is 30. So if the least number is 24 and then the greatest is 30, how do we write this or express this? It means that all the real numbers will be either greater than or equal to 24. And we are using x to express this. So it means that all the real numbers will be greater than or equal to 24, because the least number is 24. So it means that the smallest value that we can have will be 24. So all the other real numbers will be greater than or equal to 24. It means that we are going to begin from 24. All the real numbers will be greater than or equal to 24. This means that we begin from 24. Do we get it? So this is how we write that particular one. That's how we express it. X is greater than or equal to 24. And then with those same real numbers, we have 30 being the greatest number that we have in that range. And how do we express that in terms of x? It means that all the numbers can be greater than or equal to 24 from 24 upwards, but those numbers shouldn't exceed. Those numbers shouldn't be more than 30. And for that to happen, all the numbers are supposed to be less than or equal to 30. Do we get it? So this is how we express it. S is such that S is greater than or equal to 24, and then S is less than or equal to 30. That is how we express this. And finally, to write this or to put this into writing, we flip this. 24 comes first from the top, and then the sign will also change. Now it will become is less than or equal to, because 24 comes first. We have it to be is less than or equal to. Then the x comes, then this one continues. Less than or equal to 30. That's how it is written. So this becomes S is greater than or equal to 24, x is less than or equal to 30. That is the final answer. So compare with the alternatives, the one that matches this particular answer. So now we are done with question 36. Let's box on, take a look at question 37. So with question 37, this is what we have. So we have a trapezium labeled MNOP. We have a trapezium and we are supposed to find the area of that particular trapezium. So we have a particular formula that we use to find the area of a trapezium. So with the area of a trapezium, let's write that particular one down. We have area of a trapezium. And to find the area of a trapezium, the formula is given by half multiplied by the sum of the parallel sides multiplied by the height. And from the question displayed on the screen, we have the parallel sides. The parallel sides, that's the length of MN. All right, the length of MN is 12 centimeters, and one of the parallel sides too is PO, and the length of PO is 18 centimeters, and those ones are the parallel sides. So these two are the parallel sides, and the height is 4 centimeters. So now we can find the area of the trapezium. By substituting the parallel sides, which are the length of MN and then the length of PO, 12 centimeters and 18 centimeters respectively, and then the height. All right, the height of the trapezium, which is 4 centimeters. The height of the trapezium, which is 4 centimeters. So now the formula is given by half multiplied by the sum of the parallel sides, and one measures 12 centimeters. The sum means we add the two parallel sides, the length of the two parallel sides. We find their sum. So we add 12 centimeters to 18 centimeters. And then we multiply the result by the height, and the height measures 4 centimeters. So half of 12 centimeters plus 18 centimeters gives us 30 centimeters multiplied by 4 centimeters. And then half of 30 centimeters will give us 15. 2 divides itself a single time, 2 divides 30, 15 times. So we have 1. 1 out of 1 will give us 1, multiplied by 15 centimeters, multiplied by 4 centimeters. 1 multiplies 15, we have 15. 15 multiplies 4, then we have 60. cm, so cm squared. And this is the area of the trapezium. So the area of the trapezium is 60 centimeters squared. And that brings us to the end of question 37. All right, so with question 38, this is what we have. So the length of a field, 1.2 kilometers long, is represented on a map by a line 40 millimeters long. What is the scale of the map? So let's see. To find the scale of the map, if you have 1.2 kilometer, we have the line to be 40 millimeters long. So the line is equal to 40 millimeters long, and the length of the field is 1.2 kilometers long. So we are expressing the length of the line in a ratio to the length of the field. So length of the field, the length of the line to the length of the field, and the length of the line is 40 millimeters. All right, and the length of the field is 1.2 kilometers. Now this is what we have, and you know, with ratio we've got to express all the whether items or quantities in a way that they will have the same unit. So over here we have it in millimeters, and over here it is in kilometers. So this is how we go about it most often. You change the one with the bigger unit, you change it to the smaller unit, and then you leave it in the simplest form, and that will give you the answer. So let's take a look at the conversion. If you have a kilometer, it will be equal to how many millimeters? Let's take a look at this particular conversion. If you have 1,000 meters, it gives you 1 kilometer. So if you have 1,000 and it gives you 1,000 meters and it gives you 1 kilometer, it means that moving from meters to kilometers, you divide, all right, to obtain the answer. So if you are converting from kilometers to meters, you multiply by 1,000. Good. Now, What about in millimeters? If you have the value in millimeters, it will be what value in meters? Now we have 1,000 meters giving us 1 kilometer. And then when you look at conversions, when you have 1,000 millimeters, that also gives you 1 meter. All right. When you have 1,000 millimeters, it also gives you 1 meter. So if 1,000 meters gives you 1 kilometer and 1,000 millimeters gives you 1 meter, moving from millimeters to kilometer will be this multiplied by this. So it will give you 1 plus 1, 2, 3, 4, 5, 6 zeros, and that will give you 1 million. So 1 million millimeters will be equal to 1 kilometer. This is the conversion that will help us to find the answer to this. So converting 1.2 kilometers to millimeters, you will need to multiply 1.2 kilometers by 1 million to obtain or convert the kilometers to millimeters. So let's do that particular one over here. So we are going to multiply 1.2 kilometers by 1 million millimeters to convert it to millimeters. We are converting from kilometers to millimeters. So we multiply 1 million by 1.2. And you know, with 1.2 kilometers, we have 1 dp, that is 1 decimal place. So after multiplying 1.2 kilometers by 1,000, we will need to apply 1 decimal place to the final answer to obtain the final result. So we will multiply as if there were no decimal points, just as we did in the previous multiplication. So we multiply 1.2 by 1 million. We multiply as if there were no decimal points. Take note of that. So with 1.2, we write it as 12 multiplied by 1 million. And this will give us 12 million. When you multiply 12 by 1 million, you have 12 plus 6 zeros. And with this, we've got to apply 1 decimal place, because over here, after the decimal point, there is 1 digit. And that is 1 decimal place that we have over here. So we need to move the decimal point over here from the right to the left a single time. And then finally, we have this 1, 2, 3, 1, 2, 3, 1 million and 200,000. And this will be in millimeters. So now that we have 1 million and 200 millimeters, we can bring it up here because they have the same unit now, and then leave it in the simplest form. And that will give us the scale of the map. So we have 40 to, now 1.2 kilometers will give us 1,200,000 millimeters. So we have 1,200,000. So let's leave this in the simplest form. Divide 40 by 10, you have 4 left because this 0 will be gone. Divide 1,200,000 by 10, and then 1 0 will be gone. So you have 1, 2, 3, 1, 2, 3. So you have 120,000 instead of 1,200,000. You have 120,000. So over here, we haven't left it in the simplest form. So to continue, if we proceed, 4 will divide itself a single time, which will give you 1. And then 4 divides 12 over here 3 equal times. And then we have 1, 2, 3, 4 zeros. So we add the 4 zeros. So we have 4 zeros. So the scale of the map is going to be 1 to 30,000. That is the scale of the map. So we are done with question 38. Now we can box on and have a look at question 39. With question 38, all you need to understand is the conversion between the kilometers and then the millimeters. How many millimeters will be equal to 1 kilometer? And that is 1 million. Take note of that. That is very relevant and very important. So let's box on to question 39. All right, guys. So with question 39, this is what we have. There is a construction representation over here, and we are supposed to find the kind of construction that is done here. So before you be able to obtain this particular construction, let's begin like this. If I draw this and then draw this, and this is what we have, then I label here O. I stand at O, make an arc over here, and then make an arc over here. I label the arc I made over here J. I label the arc I made over here K. I stand at J, make an arc. I stand at K, make an arc. Now they intersect over here, and then from the question they have labeled it L, and then I rule a line. I rule a line through this. This means that I have divided this angle over here into two equal halves. So the angle over here will measure the same as the angle over here. So this is representing or showing the bisection of an angle. All right, so this is bisecting an angle. So the correct answer to this is bisecting an angle. What we have done has divided this angle into two equal halves. And we are done with question 39. So this is bisecting an angle, and we are done. All right, guys, so this is the last question to end the 1990 objective test. So we are simplifying this. This is what we have to simplify. So this question is under vectors, and we are subtracting this from that. So we have 2 over here. We have 2 over here minus, we have -1. So we subtract this from this, and then we subtract this also from this. So it is 2 minus -1. So that's how we write it, -1. And we have -3 minus 5. So over here we have it to be 2 minus -1. Negative gives us positive. So we have it to be 2 plus 1. And over here we have it to be -3 minus 5. And let's take a look at the result. This will give us 2 plus 1, which is 3. And this gives us -3 minus 5. And this gives us -8. This is what we have. So there's the final answer, 3, -8. We are done solving from question 1 to 40. This is the last video or the last lesson that finalizes everything on the 1990 BECE past question objective test. So we are done with this. I'll entreat you, I'll urge you to subscribe to my channel to keep the channel growing. Just watch out. 3 days from now, 4 days from now, we begin with 1991 objective test. Chill out.